Well, hello and welcome. Thanks for joining me today. This is video number 2 in an 8-part series that's going to focus on topics like the Scientific Revolution, the Enlightenment, and also a little bit on absolutism to set the context for Enlightenment thought. Today's video is going to focus on the Scientific Revolution and in particular take a look at several people that were important in the process of developing the scientific approach to things that we're familiar with today. So with that, we'll jump in with Galileo. Galileo will be an important pretty early figure in the process of developing true scientific thought. His work was done largely in the early 1600s, and there were a number of different things that he was able to contribute to I guess, show that a more objective approach to things was the way to go, at least if you wanted to understand things more accurately. For example, it says up there he learned that objects fall at a constant rate. For example, something that Aristotle had theorized was that heavier objects will fall faster than lighter objects. And when you actually drop objects that are the same size but weigh different things, they actually fall at a constant rate. Now, obviously, depending on what you're doing and what you're trying to measure, there can be some variables that can change things. But certainly, in a vacuum, it doesn't make any difference how much an object weighs. It's going to fall to the earth at the same rate. Now, it's not necessarily intuitive. It makes sense that you might think a heavier object would fall faster. But one of the key things is Galileo didn't just sit around in a lawn chair and speculate as to what might happen. He actually climbed up in a building and dropped objects and actually observed and measured what happened. And that's really what was starting to happen with this new scientific approach to understanding things. Actually experimenting, observing, seeing what happened, not just talking about it. Another big area for Galileo is with astronomy. He was able to put together a telescope where he could actually get a much closer look at the planet and just looking up into the sky. And really one of the big things that he was able to come away with from his observations there are that, and again, relative to Aristotle, who had said the planets were made of a pure, smooth, perfect substance, he was able to look closely at objects like our moon and see that the surface was rough and uneven, anything but what Aristotle had suggested. Now, as he continued observing, he didn't just observe and keep it to himself, but he wrote down his observations, shared those, and that began to create quite a stir. Now, if you recall from the first video, one of the authorities on why things were the way they were was the church, whether it was the Catholic Church primarily or really the Christian Church. And by this time, you had Protestant Christian churches as well as the Catholic Church. They had been accustomed as an institution, in particular the Catholic Church over the centuries, to being an authority on why things were the way they were. So you have people like Galileo coming out and suggesting things were different, because one of the things that Galileo was able to confirm was that Copernicus's idea about the sun-centered theory or the heliocentric theory was in fact accurate. And basically church leaders were afraid that if people believed what Galileo was saying and believed that the church had been wrong about that thing, they were worried that people would go, well, gosh, if the church said that the earth was always at the center and that's really not, what other things is the church telling us that's not true? And they were just afraid that would lead to question after question and maybe the church not being viewed credible anymore. Galileo actually got in trouble, I guess, for his views. And in fact, he even went before the Inquisition. That's a fancy way of saying church court. After he published another document, just putting information out there, the church asked him to come and basically say that he was wrong, that he didn't actually believe in the information that he was putting out. Now, to make this story really fun, you might hope that Galileo would be in defiance of the church, in defiance of all that power and authority, to stick true to what he believed. But the reality was he signed a confession saying it wasn't in fact true and accurate. And to a certain degree, that's kind of the last you really heard of him. Now, what's interesting about it is even though he denied what he believed true as being true, and the church was able to kind of shush him up, we do know today that what Galileo had observed and what Galileo was suggesting is in fact accurate. And the church would eventually acknowledge that they had been wrong and that Galileo had been right. Now, this might be shocking to you, when the church finally did formally acknowledge that Galileo was correct and that they had been wrong was the year 1992. So it was over 250 years later that the church acknowledged that they were not, in fact, accurate. In fact, I guess 350 years, gosh, even longer than it sounded like. Now, I kind of doubt the church waited until 1992 to figure out that Galileo was right, but that was at least when they acknowledged that he had, in fact, been correct. So if nothing else, just know that one of the challenges to early scientific thinking is big institutions like the church didn't necessarily want people with ideas out there that would challenge their authority. Another big development that came about during the 1600s was something called the scientific method, also something that we're pretty familiar with today. Basically, think about any science you've been in when you've been in the lab and conducted experiments. The whole process of having a problem, making a hypothesis about the solution to the problem, experimenting, collecting data and analyzing it, and then reaching a conclusion to determine whether your hypothesis about the problem was correct or not. Now, it seems pretty second nature to us, but this was a new approach, a much more objective approach to trying to understand things than had ever been true before in human history, at least in Europe up to this point. So a couple of people that were important with this scientific method development and more objective way of trying to understand things. Francis Bacon was very instrumental in helping to develop this scientific method approach. He's very much a believer in that you needed to experiment to learn something that, whereas people like Aristotle had just kind of, the way I conceive it, just kind of strolled around and looked at things and said, oh, I bet it's like this, I bet it's like that. He said you really need to conduct experiments. You really need to be able to observe what's going on to be able to reach conclusions. Now, another important figure from maybe just a different angle was a guy named Rene Descartes. You might be familiar with the phrase, I think, therefore I am. That is a statement from Descartes. And basically what it speaks to is the only thing that he was certain of was his existence. Everything else needed to be proven through logic and reason. And he was very much mathematical about his approach, whereas Bacon was more about specific experimentation. Descartes believed that you could prove things through logic, and the use of mathematics is, math is logic. And so the use of mathematical logic to reason things out. In fact, for those of you that are math students, whether you like math or don't like math, analytic geometry is a type of mathematics that Descartes developed in the process of trying to be able to reason things out and reason out an understanding of things. Now, the last person I want to speak to in today's video is another important person, really important person for how we live our lives today, Isaac Newton, the inventor of gravity. Before Isaac Newton invented gravity, things floated around quite a bit, and a lot of time and energy and resources were spent tying things down so we could function day in and day out. Hopefully you don't believe what I just said there, though he definitely helped us to understand the concept of gravity. Believe it or not, gravity's always been here. We just maybe didn't understand what it was. Anyway, one big thing with Newton, another great example of building on previous ideas. So the work he wasn't just from scratch. He was building on work that people had been doing over the previous really century plus at this point in time. And through that was able to gain a much better understanding and develop a theory of motion to give us a much better understanding of really how everything in the universe is connected together. Because what he basically was able to conclude is that with this idea of gravity, that was universal. That wasn't something that was just applicable here on Earth, but it connected everything in the universe. And that was something that was very different than what Aristotle had talked about. It's just another example of somebody sort of disproving what Aristotle had talked about, where Aristotle said there were different, every place was different, and I guess disconnected, if you want to think about it that way. Whereas Newton said, there is this one thing that connects everything in the universe, and that's gravity. And so it doesn't matter whether you're talking about a planet or you're talking about a meteorite or whatever it might be, everything, the Earth throughout the universe attracts. Now, the degree of the attraction is based on the mass and the distance between the objects. And so, think about the tides and how the ocean water comes in and the ocean water goes out. That's a good example of gravity at work and the attraction. It's our moon that impacts the tides. And so he said, again, whether it's the moon, the Earth, all of it fits together. And something else that his ideas are able to disprove is in our culture today in America, there's a false view that thin and fit is the most attractive way to be as a person. When obviously, if you study Newton's laws, you understand that the more massive you are, the more attractive you will be. Something to keep in mind when thinking about connecting with other people. Use science. It'll help you out. That's where we're going to leave things for today. Hopefully, you have found this video informative and helpful and have a little bit more insight into some of the early innovative people with scientific thought. Our next video is going to shift into the topic of absolutism. Hopefully, you'll join me then. Thanks for watching.